right, then I'm gonna go to my screen so we can start our notes. All right, y'all, so we're in 9.4. And that'll be logarithmic functions.
Tons of fun.
Oh, got another one coming in. Okay, so we're going to look at first at graphing them, and I'm going to show y'all how to graph these on the calculator. So they want me to graph y equals log base 7 of x. Now, most of our calculators had the log base on it, but some of us like Kelsey, when you graph this, you're going to have to do, in your y1, you're going to have to do log of x divided by log of 7. And you'll do that every time when we're doing these with the numbers down here shown as a base, okay? Now the rest of it, if you had the log base, what we would do is go to y equals. I'm gonna clear that one out. And to get that log base, we would hit math, and then we would arrow down until we found our log base. Hit enter, and then you would put your 7 as the base like they had, and then arrow over and put your x. So with the log base, we can actually make them look exactly like that, okay? So to get that log base, remember I hit math, and then I went down to find log base. All right, so we want to see this graph, so I'm just going to hit graph. And you notice the logs sort of come up and then gradually grow as they go, okay? And remember, that's because we're finding exponents on these logs. So they'll be a little bit less steep as the other graphs we did.
So for this one, you asked us to do math, log, and then a small 7, and then the x inside the parentheses and push graph. Mine didn't do that, but.
Is it looking like my screen? Can you see?
Yeah, let me see. Oh, I got to do it in the y equals. Okay. Just ignore me. I'm good.
Yeah. If you just do it on the regular calculator, it's going to try to find those answers.
Okay.
Now this one I had a f of x equals log of x. So here's the thing on this. Anytime you got a log that don't have a base by it, that would be a log base 10. So and here's a log on your calculator on the very front by the 7. I'll just hit that when I get a log like that, okay? So if it don't have a base, I just use the log that's on the front of my calculator. So this wanted me to find log of x, so I would just hit the log button. Well, let me clear that out. So hit your log button, and then just put your x inside those parentheses. Now, Kelsey, yours will even do this part, okay? And then I got log x, and then I hit enter. And notice it's about the same kind of graph. It's just going to come up and slowly grow as it goes, okay? And y'all, that's just because it's finding those exponents, right? You see where it crosses 1 here? It's right on the y-axis where it crosses 1 at, because 0 is the exponent you got to raise stuff to get a 1 out of that, okay? And then once again, you can always go to your table and go down through there. So you see when x is 1, the exponent had to be 0 for that, okay? All right, then the next one we'll graph real quick is f of x equals the ln of x. So a ln is a special log. It's a log base e. And the ln is right next to the 4 on your calculator. So since those are our special ones, they keep them on the top of the calculator. Anything else, I got to go into the math and do the log base. So we just hit y equals. I'm going to clear that. Hit my ln button, which is natural log is what that actually means. So that's the natural log, that ln. And then I'm putting in what? My x, close my parentheses, and hit graph. But y'all, for the third time, since it's looking for exponents, it's going to sort of slowly grow, just like the rest of them have.
So we do ln, we go into the graph, and then it says y equals, and we push the ln button.
Right.
And then we put the x in parentheses.
And just put the x in and be done.
Okay.
And then that should give you sort of a little graph like I got up here.
Yes, sir.
Okay. All right, so that's just showing you the 3 things you might have to graph. If it's got a base like this 7 on the first one, use the log base, or Kelsey would have to do the log x divided by the log of 7 on those. The log and the ln both have them on the front of the calculator, so everybody can do those problems, okay? So now we're going to do those examples where we're going to find the logarithm. And I sort of gave y'all a little bit of definitions the other day. So let's see. This one is a log base 5 of 625. So I'm looking for an exponent on this problem. I'm looking for the exponent that I would raise 5 to make that 625. So we got 5 to some exponent is going to equal 625. So one way to do these, remember you got that log base button. So you can hit your math and go down to log base. Hit enter. So my base was the 5, and then my result was the 625. Now, Kelsey, on this one, you could do log of 625 divided by log of 5. Kelsey, just remember to close in parentheses when you're doing them logs on that, okay? So, what exponent would y'all raise that 5 to make it a 625?
4.
So 4, right? Because 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. So the answer for that is definitely 4. They're not bad. You're just looking for those exponents, okay? How about this one, y'all? Log base 6 of 36. So 6 to some exponent is going to equal 36. And what y'all putting there?
So should that be like a 1 or like a 6, like a 2?
A 2 would work, right? 6 times 6, 2 times is 36. So the first one we got a 4, second one we got a 2. All right, so let me throw the first curveball at you. How about log base 10 of 0.001? So let me show y'all something you can do on this calculator to figure this out in exponent form. I'm going to change my mode for just this one problem, and I'm going to set my mode. So y'all watch, I'm putting my mode here. Where it says normal blinking, I'm going to put it on science and hit enter. So I'm now on science mode, because watch what I can do when I clear this screen. I'm going to put in 0.001 and hit enter, because this will write it as an exponent. So when I hit enter, that gives me 10 to the negative third, right? which is the same thing as 0.001.
Mm-hmm.
So, you'll see what I did. I just put my mode on engineering real quick. Now, I'll probably switch mine back for normal operations. I just wanted it to take care of that decimal real quick. But now I got log base 10 of 10 to the negative third. So think about this. What exponent
So
would I
whenever
raise?
I put it in, it did give me -3.
It did what?
It did give me -3 before I changed my mode, but then now it gives me e to the 0.
Okay, so if it was working before, I would just leave it like that.
So it's fine to just put -3?
That's the exponent, right? Well, mine does 1e -3. This is scientific notation mode when it does that. It's like 1 times 10 to the negative third. But all I wanted to do was just rewrite that decimal as a negative exponent. Decimals you write as negative exponents. Fractions would be written with negative exponents. Have y'all forgotten about negative exponents? I'll review you real quick. So let me show you how I got a -3 out of that. So I'm going to play with the 0.001. I'm going to write that as a fraction. So that's 1 over something. So let's see what we got. There's my 1 unit. So there's a tenths, hundredths, thousandths. So that would be 1 over 1,000. Now I'm just showing you how to turn the decimal into that exponent, okay? So can I rewrite 1,000 as 10 to an exponent? Yeah, I can write that as what? 10 to the third, right? Because 10 times 10 is 100, times 10 is 1,000. But remember, if I don't want this 10 to be under the 1 and I want my 10 to be sitting up there as the number, what do I have to do to this exponent if I bring that 10 up? You got to change it. You got to change its sign. There you go. So anytime you move an exponent up or down, you change its sign. So that's how they got that 10 to the negative third, okay? So our question was, we got 10 sitting here. What exponent would we raise 10 to make it equal a 10 to the negative 3? And the only answer is a
3.
-3. So y'all watch this. When this base matches that result, the answer is always going to be that exponent. Okay? So watch this. Log base 10 of 10 squared. So really, what is 10 squared equal? It's 100, right? So what exponent would I raise 10 to make it equal 100?
2.
And that would definitely be a 2. So if the bases match, the answer is always going to be that exponent that's sitting up here, okay?
So you're saying, how would we put that into the calculator though? I mean, I guess we don't ever need to. We just use
I can do that. This one I just did, log 10 of 10 squared. Remember, since that's a log base 10, I can use log that's on the front. I can use that log that's on the front and then put in my 10 to the second power. Whoops, I don't like how that did that. And then how about that 10 squared? And when you hit enter, you're going to get that 2 out of that, okay?
Okay.
So if I just got a log, I use
when they don't match.
Do again?
What about when they don't match?
If they don't match, then I'll use that log base that's down in there, or it'll just basically find those exponents that made that base equal that number. How about log base 4 of 1 over 16? Now the calculator spit that out quick. But you remember what I did to that decimal a while ago? I can do that with this 1 over 16. Since that's a base 4, I can make that 1 over 4 squared. Now to bring that 4 up, that 2 is going to become negative.
Negative.
So that this becomes 4, base 4 of 4 to the negative second. All right, which means the answer is, since now I got it written with my base matches that result, the answer has to be at negative 2. So y'all watch this. I said the answer was negative 2, so let me try and check it. So 4 exponent negative 2 equals 0.0625, but when you hit math and turn it into a fraction, you get 1 over 16 back, okay? So fractions and decimals will usually have those negative exponents. Danielle, that brings back memories, right? Maybe. What about this? Log?
Definitely the part of that class I hated.
Well, what are y'all putting on this? I got a log, which means it's really a log base 10 of 10. So what exponent am I raising 10 to make it a 10?
1.
1.
And that works for anything that matches. So if you had a oh hell, what about a heart to a heart? Log base heart to a heart equals?
It'll be a heart.
It equals?
A heart.
Heart.
It equals?
1.
1.
1.
Okay.
That's right.
Oh,
So heart to the first power equals heart, right? Smiley face of a smiley face would still be a 1. So remember, that's just because that's an imaginary 10 sitting on that, okay? How about ln?
I'm putting smiley faces in my notes.
What about the ln of e? Remember, the ln is a log base e. So you got a log base e of a e, which is going to equal?
Is that a 1?
A 1. There you go. Log base 4 of 4 to the third is going to equal. So what exponent can you raise the 4 to make it look like a 4 to the third? And that would definitely
That would be 3.
A 3. These ain't too bad. It's just you got to realize you're sort of undoing things that were exponential and being squared and cubed and all that fun stuff. All right, now let's turn it up.
So are you saying that if the not the log base, but the other number, if it has an exponent with it, it's always going to be that exponent?
If these two numbers match. So if that log base matches the result being raised to the exponent, then the answer will always be that exponent, okay? But had this been
so
like
if that was like a 3 and a 5,
then I wouldn't.
to
I
the
would have
third,
to just,
it wouldn't be the 3.
right. I would just punch it in my calculator probably and get some kind of ugly decimal out of that.
Okay. Just wanted to be clear on it.
Mm-hmm. Oh, no problem. So this one. Oh, that's a log base 5. So log base 5 of the 6th root of 5. So what I would do to that is rewrite this radical as a exponent. So that's going to give you log base 5 of 5, because 5's the base, the exponent on that would be a 1 over 6. So you rewrite radicals as fractional exponents, and I'm going to give you that definition here, right here.
So where is that 6 supposed to be? Like, oh, it's on the outside of the radical?
Since it's on the outside of the radical, it's like the index of the radical. Okay? So let me think. If y'all ain't familiar with the roots, so remember, y'all familiar with square roots, right?
Mm-hmm.
Square root of 25 finds a number twice that equal 25, which would be what, a 5? A cube root of a number finds a number that got multiplied 3 times to make 27. So that would be what, a 3? So whatever these roots are is how many times a number got multiplied to get these numbers under those radicals. But we're not going to kill you on that. You just got to be able to rewrite it. And since there wasn't an exponent by the 5, I would treat it like a 1, so that when you rewrite them, the exponents are on top, and these roots or indexes always went to the bottom. But now look what I got. I got log base 5 of 5 to the 1/6. What's my answer?
1/6.
1/6.
1/6. There you go.
So it's hard for me to understand like why just yet because this is new, but like I understand that it's 1/6. So is that like good enough for now? Like if we just keep practicing?
Yeah, just remember. So like if you can't square roots, you can always use the fractional exponents to do square roots and all that, but now we won't worry about that.
Okay.
Log.
So you said in that problem that 5, the exponent was 1, right? Are we gonna have problems where the exponent is not 1?
No, probably not in this section.
Okay.
No.
You said that, so I was like, oh God, here comes the question.
No.
Not gonna be 1.
I think that's the only one on there that you actually had to transfer out of the radical to be able to do it. In our calculators, to do that is sort of tricky, but let me show you. If you got time to play with it, I'm gonna hit my log base.
So that 10 right there is a big number. That's not a little number.
Yeah,
that 10?
No, the base would be a 10 also.
Oh, okay, I hear you.
It's like it'd be like that.
Okay. Sorry, go on.
But that last one I could have done on here, let me see. I could have went to log base, so that had a 5 there. And then this was a 6th root of a 5. So to do that, I would have to hit the 6, math. Where's one that's got has that got an X in front of it? And then put the 5. So y'all see how I made it look just like that problem, right? Log base 5 of the 6th root of 5, hit enter. Now I don't want the decimal, so I would hit enter one more time. And that gave me, was that what, a 1/6 like we got a while ago? What's the answer to this? And log base 10 of 10 to the -4.
So we can put it in the calculator just like that.
But this one you don't have to. That's too much work.
Yeah.
Log base 10 of 10 to the -4 equals?
-4.
-4.
-4. But you could have put it in the calculator and it would have spit out that -4 quick, okay?
If we forgot how simple it was.
Right. Log base 81 of 3. So that, and if you're not good at roots and stuff, I would probably just punch this one right in the calculator, go to your math, go to your log base. That's an 81 for the base, and 3 is the result. And then you hit enter, 0.25, but remember I hit math and enter twice, and I get 1/4. That means you got to take roots to turn an 81 into a 3, right? Because that would be 3 times 3 times 3 times 3, 4 times to get back to that 81. So when your results are smaller
Are you doing
than
okay, Kelsey? You're quiet.
on that, and Kelsey would do this, log 3 divided by log 81. So y'all watch this, log 3 divided by log 81. And we still get 0.25, which is 1/4. So just another step or two on that, doing it that way, but it works. All righty, log base 12 of 1. So what y'all putting on that? Log base 12 of 1. What exponent would we raise the 12 to turn it into a 1?
12.
All 12 to the 12th is like 144.
112. I don't know.
Well, let's try this. Kelsey, we'll do it your way. Log.
It says 0.
0. Okay, thank you. So watch this. Log 25 of 1 is going to equal what?
Oh, sorry, 0.
So no matter what I got for a base, if that's a 1 for that result, your exponent will always be 0.
0. Trying to follow along here. Waiting for this coffee to kick in.
Right.
Right, ln e to the 3rd. Now remember, this is really log base e of e to the 3rd. So since that base and result match, I know the answer was definitely that exponent 3.
So that's an equal sign, right? That's not a is congruent, right? Just making sure you're not throwing no tricks on me.
No, I get a lot of times when I do these, because they're decimals, I just use them crookedy ones, but no.
Yeah, okay.
It's an approximation.
There you go.
Oh, yeah, that's right.
Oh, look at that. So I lied. There was 2 with a radical. But remember, we could rewrite this as ln of e to what exponent would I put?
Is that a 7?
It's 7, so I'm going to put a 1/7 for my exponent.
Oh, yeah, okay.
Remember, the e technically would have its 1 by it, okay? Which means ln, since that's a log base e of e, those match, so your answer has to be
1/7.
1/7.
I like vaguely remember doing this in high school, but it's also been like 10 years. So
I don't remember nothing about it. This is new territory.
So what we're going to do now is we're going to convert exponential to logarithmic. And this will sort of get us ready for doing equations in the future. So it all goes back to that little definition I gave y'all the other day. Log base b of y equals x if and only if y, whoops, hang on, b to the x equals y. So remember, base, exponent equals results, okay? And this double arrow means if and only if. So the first one they want me to convert is 10 squared equals 100. That's the exponential form, and we're going to rewrite it as logarithmic. So you bring down your log. First of all, we got to figure out the base. Well, the base is a number that's being hit with the exponent. So this would be a log base 10 The result would be the 100, and that's going to equal the exponent of 2. So we're basically just doing this. B was my base. Where am I at? 100 was my result, and then 2 was the exponent, and then we move on.
Huh.
8 to the 1/3 equals 2. So we're going to write it out as a log. The base is the number being hit with the exponent again. So the base is our 8. The result is the 2. And then the exponent I would raise 8 to make that a 2 would be a 1/3. Which means they took a cube root of that 8 to get that 2, okay?
Huh.
I didn't mind these parts because all you're doing is really just rewriting them over. How about this? E to the -5 equals K. So I'm going to bring down my log. I know my base is the E. The result is the K. And that's going to equal the exponent of a -5. Now, have I wanted to, this log E I could rewrite as the ln. And I could make this a ln of K equals -5. So either way, I think the math lab would take that either way on those. Okay. All right, so let's try one more.
That ln and K look like ink.
It looked like what?
It did, huh?
I said that ln and K look like ink.
Oh, ink. Oh, and let me say this too. When y'all are
like
doing
the word ink.
but listen, when y'all are doing the homework in this section, that is a LN, not a IN. And people put IN and they miss it because they're not putting a little L and an N. When you put it in MathLab and you put LN, it makes it, what do you call it, bold. Does that make sense? It highlights it bold when you do it right.
Makes it what? A bold.
Bold, like thin to thick.
Well, we won't make that mistake because we won't make that mistake.
I hope so.
You told us that it stands for natural log.
Right. All right, y'all, here we go. Log.
Well, I might, but.
So the base is my P again. My result is that 34. And that's going to equal the exponent of a W. So now we're going the other way. We're going to convert to exponential. So log base 5 of 625 equals 4. So to rewrite it as exponential, I still need my base, and my base is sitting down there at that 5. So what's your exponent? It's going to be my 4. And I know that 5 to the 4th power equals 625. Oh, let's see what we got here. Log 0.001 equals -3. Oh, I'm stuck. I don't know what my base is.
10.
And there you go. And then that makes my exponent what? The -3. And we know that 10 to the -3 equals the 0.001. 0.001. All right, log base n of r equals negative y. Oh, let me make that an n. It don't look too much like an n. There we go. So base is the n. Exponent is what? The negative y. And n to the negative y will equal the r. Now we'll say this one, if they use little letters, use little letters, and if they use capital letters, use those, because it's really picky on the way they're written, okay? All right,
It's
so
the math
now we're going
lab.
to use a
It's
calculator.
always going to be picky.
Oh, you know that math lab is. All right, so use a calculator. To find the common log. And then we're going to round 4 decimal places. So first of all, I'm going to do log of 80. So now I can use my crooked parenthesis equals, right? Because we're approximating. All righty, so we all got this calculator button on the front. So log is right next to the 7. So I'm going to hit log, throw in my 80, and enter. Now I'm going 4 decimal places. So let's see what we got, a 1.903. So what y'all putting after the 3?
1.
And a 1, there you go. Okay. Now, let's think about this. Does that sound reasonable? You got a log base 10. The exponent they're giving me is between 1 and 2. Well, I know that 10 to the first power is 10, and I know that 10 squared is 100. So since 80 is in between 10 and 100, it only makes sense that the exponent is in between a 1 and a 2. Okay? Just like this in 44, it's in between 10 and 100. So I'm expecting its exponent to be 1 point something, something, something. So let's try that. Log 44, enter. And this time I get 1.64.
1.6435.
35, okay. Log of a negative 24. And then remember, that base is what? 10 still?
I get an error.
Error?
Yeah, I got an error too.
Oh, which? And he got an error too. Because guess what? You telling me there's nothing I can do to this 10 to make it a negative 24? Right, no matter what
It
exponent
says it's not a real answer.
right, because there's no exponent I can put in on a 10 and change its sign to a negative. So, good job. If you get that
To a
error,
negative.
and it's a non-real answer, that means we'd have to do the imaginary stuff to get those. So for us, we're going to put does not exist. And then I'll write that out. Does not exist. In the real world, right?
Can you do the line with the 0 with the line through it?
Oh, well, this one just has like A would be the answer, and B, it says the answer does not exist.
Okay.
So, all right, so now we're going to use the calculator. To find the natural logs. And I'm going to round these ones 4 decimal places. All right, so this one has a LN 727.1. Now, they're just going to throw out some crazy numbers on you just to get these done, okay? But now, let's see. We do have an LN button on the front, so I'm going to use my LN button. And then 727.1. And then enter. So, y'all, it looks like, what, a 6.5. I think that's a 8, 9.
5, 8, 9, 0, or do you do 1? You do 1, huh?
It'd be a 1 there, yeah. I'm just trying to figure out, was that an 8 or a 0 after that 5, but it's an 8. So 6.5, 8, 9, 1. LN of a negative 1.13. Oh, y'all are already doing too much.
It's not real. It does
Yeah.
not exist.
There's another negative on it, right? So that does mean does not exist.
You know, Mr. Rathon, we just had to test the theory. You know, we had to see it for ourselves. Seeing is believing.
Mm-hmm.
Hey, at least we're making sure.
Right.
And we're not just
we'll call it
throwing something out
making
there.
sure. We won't call it
Yeah.
ignorance. We'll call it making sure.
Hey, ignorance is bliss sometimes.
All right.
All right, so the last.
I don't want to throw myself under the bus, you know? I do that
This
enough.
wants me to use the change of base to find the logs. Log base 4 of 50. Now, those newer calculators, I'll just probably use log base on that. But this was so that ones that had the older calculators can still do these. So change of base means I'm going to take the log of the 50 and divide by log of the 4. Now, here's what's nice about these. You can use a log for both of these, or you could use the LNs for both of these and get the same answers. So when you punch in this log, 50, close those parentheses, and then do divide by log 4 and close its parentheses. If you don't close parentheses on the 50, it will definitely mess this problem up. All right, so I'm getting what, a 2?
So when you're putting it into a log base,
Uh-huh.
when you're putting it into the log base, it's going to be log 50 and then 4.
Okay, so if you're doing this other one, if you're doing log base, make it look exactly like that. Whoops.
So you put the log 4 of 50? Okay.
So let's see. Yeah, I would put my 4 on the subscript, and then I would come up and put my 50. And then I should get that 2.81821928 blah, blah, blah when I hit enter. And there you go. So either way on that, what's also nice is if you did the LN of 50 divided by the LN of 4, you would still get 2.8219. So no matter which base you used,
Go give me a diaper.
You'll still get the same answers. All right, log base 4 of 70. Which would be what, a log 70 divided by log 4. Or use the log base like y'all were doing. So let's see, log 70 divided by log of 4 equals, what's that, a 3.064. I guess I'll keep that a 6. Oh, this is not too bad a section. It's just really punching everything on those calculators. Log 500 of a 15. So that definitely better be less than 1, because 500 to the first power would be 500, and whoo, that 15 is a lot smaller. But on this one, it would be log of 15 divided by log of the 500. It's always, the 15 looks higher, so it's on top. The 500 looks like it's lower, so it goes to the bottom. So let's see, log of 15 divided by the log of the 500.
Are we rounding these?
4 decimal places. So that'd be what, a 0.435?
576.
So
Oh,
why
round
do
it.
we have to do that division and all that? Because if you just put it in with the log base, so why do we have to do all that?
So
In
the
case there's one
reason,
that- yeah.
so the reason we learned this was because the older calculators didn't have the log base in it.
Ah, okay. That's right.
So if you got like an older
Mr. Rathbun, I
83
got a different answer.
on the one I just
Right.
did. So watch
Mhm.
this. Math, go to log base. I'm gonna try it that way.
So this is the way you've been explaining to Casey either way. Or
500.
Kelsey, sorry.
No, they about the same, Danielle.
I got 4.3575.
Oh, I wonder what did you put in it? Did you do log 15 divided by log 500 or 50?
I put log 50. I would put log 500 and the 15 in parentheses, like we've been doing.
Oh, so like mine looks. So I'm trying to figure out why yours ain't. Trying to figure out why yours is doing a 4 point.
Can you see that?
Well, I can't see real good that screen. I can see it's a 4 point something though. Let me see. No, that ain't what it was. I don't know what you did, girl. We'll figure it out in a second.
Hold on, I'm fixing to take a picture of it.
Okay.
I just sent it to you, Mr. Rathbun.
Okay. On my phone?
Yeah.
That x should be an exponent, right?
Mm-hmm.
That x should be an exponent, right?
Yeah, I got f of x equals 3 to the x. And then this one is f negative 1 of x. Remember, that's inverse notation. Remember, f inverse from a while back is log base 3 of x.
Did you
And
get
all they
that,
wanted me
Mr.
to do,
Rathbun?
and what they wanted us to do was just graph these so that you could see what inverse functions would do when we graph them. So let me see. Let me go to her picture. Oh, okay, Danielle, do this on your calculator. Go back to your mode and put it on normal and float. And then maybe it'll take care of that doing them negative exponents like that.
I did it.
Okay. All right, so this one, what they want me to do is graph both these and just look at their pictures. So I'm going to put the first equation in y1 and then the second one in my y2. So for y1, I'm just going to go 3 exponent x. Then I'm going to come down here to my y2 and do log 3 of x. So I'm going to hit math and go to log base. And then that would be a 3 and an x. Now, Casey, just remember on this one, you'll have to do log of x divided by log of 3 on that one, okay? Alrighty, so they just wanted us to see how these were inverses. So when you graph, the first graph is going to be the 3x, and we know it's going to go uphill. And then the second one is going to be the logarithm, and we know it's going to sort of slowly rise. So y'all, they have 4 pictures, just pick the one that you need. Now here's the thing about these inverses. They don't cross over each other, okay? And I think most of their other pictures, they all were crossing over. So. Alrighty, that's 9-4, so I might get some definitions going for y'all. For 9-5.
Can you do another one of the graphing?
Oh, you want more?
Yeah, at least one more would be good.
So let me graph. So I got to find them to be inverses. So f of x could equal 5 to the x. My f inverse of x would be log base 5 of x. And you'll notice, if you see how my graphs are, these will be pretty much the same way when we do this. So let me clear these out. So up here I had what, 5 to the x. So I'm gonna do my 5 and exponent x, and then I'm gonna go down to y2 here. And that was what, log base 5 of x. So I'm gonna use the math and that log base. Oh no, not this time. Let me do the other way, because I did log base last time. So this time, to make it look like Kelsey's, I would do log of x, close parentheses, divided by log of 5. All right, so, uh-oh, y'all, I'm gonna mess up if I don't put something here. I got my log there, let me, okay. So now hit graph. And you should have one graph going uphill still for your log, exponential. And then here comes that logarithmic coming back down the bottom. So y'all, no matter what your basis is, those graphs will look similar to that, okay?
I got 3 lines.
Oh, you must have another graph on somehow. Anyway.
Oh my God.
And so for my notes, for whenever I go back to review this later, like for this problem that we just did, can you write it like, you know how we entered it like we would in Kelsey's calculator? Let me see. Yeah, let me write. I gotta write that. Where you do the dividing, the log divide.
Oh, right here. So that there was the change of base.
Oh, I see. Okay.
All right, so I'm gonna get y'all started on my properties, but we might not do too many of these. So 9.5 is properties of logarithms. Now, logarithms, since they are like exponents, have rules just like exponents. So the first one I'm going to look at is the product rule of logarithms. So if I got a log of a product, I can rewrite that as a sum of the logs. Log of x plus log of y. Remember, when you was multiplying them variables, what did you do with those exponents? You added them, didn't you? Like an x to the second times an x to the third, you added those and got an x to the fifth. So the log of a product is the sum of those logs. You had a quotient rule of logs.
So that x and that y up there are big numbers. They're not small numbers.
Right, they're all big. We're just going to treat them all like they're base log 10s or whatever.
Okay.
So the quotient rule would be a log of x divided by y. So what'd you do when you were dividing those exponents on them variables? You subtracted them, right?
So it'd be a log of x minus the log of y.
There you go. And just remember, that's the same as when you had the x5s over the x2s. You subtracted 5 minus 2 to get the x3s left, okay? There's a power rule of logs. That'd be like log of x to the y. And that's just going to equal y log x. So what you do, anytime you got an exponent up here, you bring that exponent down to the front. So if you remember, when you had something like x to the third raised to the second power, you multiplied those exponents. Well, that's what this is doing. This is taking that exponent up here, bringing it down in front, and multiplying by that exponent. So still really following that same rule, okay? All right, then the last thing would be to remember that the log base x of x equals 1, right? Anytime the base matches the result, it's going to equal a 1. So watch this. We're going to express as a sum of logarithms. So I got log base 6 of 6 times 36. Now, they don't want us to multiply this. They just said, hey, we got some number here. We're going to break it down into factors. And we just want you to write it as a sum. So that's going to be a log base 6 of 6 plus a log base 6 of 36. Now, they don't want me to go further on this because I could turn this into a 1, that into a 2, and all that fun stuff. They just want us to stop after we rewrite them. ln x times y. So notice I got my product, which is the x times the y. So I'm going to, you're basically distributing these ln's and stuff. So that this will be a ln of x plus ln of y. Express as a product. So to express them as a product, you're looking at the power rule here. So how about this one? Log base 10 of y to the 16th. So y'all, what did I do to the exponents on that power rule? So this 16, we're going to bring it to the very front so that we get 16 times the log 10 of y. So the power rule, that's all we're doing is bringing those exponents right down to the very front, okay? Question on that? All right, same thing, y'all. ln fifth root of 3. So I think what you're going to have to do to that one is rewrite that radical with the 5 on it. In exponent form, it will be like a fraction. The top number will be the 1 that's by the 3. The bottom number will be the 5. So now that we've got it written right, rewriting it as a product, I'm going to take this exponent of 1/5 and bring it to the front so that I get a 1/5 times the ln of 3. All right, expressed as a difference of logs. Oh, don't worry, y'all. They turn it up a little bit on the heat a little bit later. Okay, watch this one. Log.
I thought you were supposed to encourage us.
Log base c of a d over 7. So expressed as a difference, that means they're subtracting exponents. So that would be the log base c of d minus the log base c of 7. And the main thing you got to remember is to distribute that base with those logs when you do these, okay? All right, where's that other one, okay? ln of v over w. And remember, it's pretty much like the exponent rules. It's always the top minus that bottom, so I'm going to have an ln of v minus the ln of w. All right, so I probably got time for, let me try one more at least. I'm sure we can get this one in here. So I'm going to rewrite as sums or differences of logs. So I got a log base b of, oh man, broke my pen. All right, hopefully I got another pen up here. All right, we're good to go. All right, log base b of x to the 3rd. And let me make this one right. All right, x to the 3rd, y to the 6th, and a z. So first of all, I'm going to rewrite the product as a sum of logs. So the first step I'm going to do is log.
Is it glitchy for anybody else, or is it just
Yeah.
me?
What's glitchy? Am I talking or am I writing?
Your voice is like very it's very, you're right, your voice, it's very glitchy like a robot. Like sometimes we don't hear you.
It's probably that, what they call it, bandwidth stuff. All right, so I'm going to distribute my log b to everything. So I get a log b of x to the 3rd plus a log b of y to the 6th plus a log b of z. So if you had 3 products here, you're going to have 3 little terms down here when you add them. Now there's one more thing I got to do to this. And it has to do with that power rule. I got exponents showing, right? So remember that power rule up here we just did a while ago.
You got to put them at the beginning.
I got to put them at the beginning. So the 3 has to come up and the 6 has to come up. So we get a 3 log base b of x, plus I get a 6 log base b of y. And then at the end, I didn't have to do nothing to that. So that's just a log b of z. All right, y'all look like y'all want one more good one, right? So here we go. Log base b of p to the 3rd, q to the 7th over m to the 5, b to the 7th. So I'm going to tell y'all a trick on this. If it's on the top, they're going to be positive. If they're on the bottom, they're going to be subtracted. So we're going to add the ones from the top, but we're going to subtract the ones from the bottom. So I'm going to rewrite this as one long sentence. So I'm going to do log b of p to the 3rd plus log b of q to the 7th. So on top, they're positive. Now remember, since these ones are on bottom, they're being subtracted. So that would be minus log b of m to the 5th. And then minus log b of b to the 7th. So notice I distributed the log b to both on top and both on bottom. If they're on bottom, they're using that quotient rule and being subtracted, okay? So y'all, the next thing I'm going to do, everybody's got exponents that are being moved. So we're going to move all the exponents up front. So I get 3 log b of p plus 7 log b of q minus 5 log b of m minus 7 log b of b. Oh, these are so fun to write because you don't really get to get rid of nothing. It just moves around. And I'm going to tell y'all I got one more move I can do to this problem. So let me look. Can't do nothing in that one. Can't do nothing to that one. Can't do nothing to the 5 log. But I can do something to that one. What's this log b of b part equal?
1.
So since that part equals 1, 1 times 7 will make that a 7. So I'm going to rewrite this as 3 log b of p plus 7 log b of q minus 5 log b of m minus 7. So anytime you get a base that matches the result, you got to turn that into a 1, okay? All right, I think I've messed y'all's mind up enough for this point.
Did you write -1? Is that what that is underneath that b term?
No, that's the equals 1. Equal 1.
Okay, don't flip the page or nothing.
And that's probably the last one I'm doing today, so I just wanted to get a little bit of start on that. So next class we'll finish this out and start doing them with those equations. So y'all should be able to work up to number 9 for 9.5, okay? And we're going to start at number 9 next class.
I actually already did either to, I think 5 or 6 the other day.
Oh, you're rolling then.
I think so. Because, I mean, I knew it was like the same multiplication laws.
Right. All right, so let me stop this sharing. And then I'm going to stop this video.